All right, so we're going to do 1/6 right now. And it's called two-dimensional figures. I didn't write that on there, so I'll do it right here. So it's called two-dimensional figures. Remember, we skipped ahead to 1/7, and unknowingly, I skipped ahead to 1/7. I forgot we didn't do 1/6. So 1/7 was 3. Yes. What? A test is 100. All right, I'm in the middle of talking. That could have waited to the end, couldn't it?
Yeah.
Instead of me in the middle of trying to do a lesson. So let's try this again. On 1/7, we did three-dimensional figures. All right, so this is two-dimensional figures. I was supposed to teach this first, but it really doesn't make any difference. So let's talk about the first word, and let's draw it. I'm sure everybody knows what this is right there.
Circle.
That is a circle. It's a circle.
You're done.
All right, so there's a couple things about the circle we need to know. And let me do this. It's not a sphere. This is just a circle. All right. There's a point right there. What do you think we call that? It's right in the middle of the circle. The center of the circle. No, it's not a midpoint. It's the center of the circle. And then if we draw a little line segment from the center, anywhere on the circle, doesn't matter. I mean, I could take this anywhere on the circle that I wanted. I'm just going to put it right there. Yeah. This is the radius of the circle. All right, pretty easy. Let's name it. Let's call that C. Let's call this B. So we actually have a way to name a circle. We're not going to be doing a whole lot with circles in this chapter. There is an entire chapter, a whole entire chapter just on circles. All right, so we're just barely scratching the surface today with circles. But there's one thing, we need to name the circle. So if I wanted to name the circle, I use the center of the circle to name it. So you just use one capital letter. Use the point that's the center of the circle. So what point is at the center of the circle?
C.
It's C, so we call it circle C. But we have a little symbol for circle. It's just a little circle with a dot right in the middle, okay?
And that means C?
That means circle. Doesn't mean C, it means circle. And then you put a capital C. So what does this whole thing right here mean?
Circle
C. All right, and that C tells you the center of the circle. It could be any letter. They just happen to use letter C on this one. All right, and if I asked you what is the radius of the circle, then what would you tell me?
Circle C.
The
C.
radius. If I asked you the radius, you would say circle C.
Radius. I would probably say CB. CB.
What is it? Is it a line? Is it a ray? Is it a line segment? Is it a what is it?
Line segment BC.
It's a line segment. That's not a line. A line would keep going forever and ever, right? Then the radius to every circle would be exactly the same. It would be a never-ending line. So it's not, okay? The radius of the circle is a line segment. It goes from C to B, right? So how would we write it? CB with a little line segment over top of it. You can. You can go BC if you wanted to as well. All right? So if I asked you to name the radius of that circle, you'll use either one of these, or line segment CB or line segment BC. This is kind of preferred. Why do you think that would be preferred? Yeah, because it starts at the C. Okay, the center is the first one, but it doesn't matter, really. Okay, so the or still stands. You can write it either way if I ask you the radius of the circle. But it's a little more consistent if you say CB, line segment CB, because C is the center, and if we want to know what the center of that circle is, you can just see the first one. But it doesn't really matter, all right? Let's keep going. Now, this is I didn't really give you a definition of a circle. It's the set of all points in a plane that's a given distance from a given point. So this is the given point, the radius is the given distance, and it's all. So what if I did this? What if I did this? And I'll say that's A. So it hits right on the circle at A. So what do you think line segment AC is? It's also the radius, because it starts at the center and it goes to a point on the circle. So this point right here is where? I just said it. It's on the circle. It's on the circle. So that point's on the circle. This point's on the circle. I could call this D. I could call this E, right? And if I just connect the center of the circle with any point on the circle, any point on the circle, then we could consider that a radius. So there's a whole bunch of radiuses. What's the plural? Is it radiuses?
Radius.
Say it. Radii. Yep. The plural is radii. So radius is singular. Radii. Okay. There's how you. So everybody look up here. Up here. Up here. This is the plural for radii. For more than one radius. Okay. I'll put plural right there. All right. So I think it's important to know that. Yeah, so how many radii are there on a circle?
As many as you put.
As many as you put. There could be as many radii as you want to put on there. Okay, so there's an infinite number of radii to one particular circle. Agreed? But we usually just name one or two of them or something like that. Okay. Here's another word. I think we're going to talk about it later, but since I'm looking at it and thinking about it, what if I did this? And I call this, what a letter, let's put an F right there. What if I said line segment FB? It's the diameter. So line segment FB, look what it does. It goes through the center, right? But it hits, the endpoints of that line segment are on the circle itself. See, this is on the circle. What if I put a point inside of here? Would I say that that's on the circle? It's in the circle, okay? This is in the circle. What if I put a point out here?
That's exterior.
It's exterior, or you can say it's outside the circle. Exactly right. Everybody with me?
Yeah.
Okay. Well, what about FB? What's that thing called? I heard already. Somebody said it.
Diameter.
It's a diameter. All right. Now, what's true about the diameter is it has to go through the center. All right. The diameter has to go through the center. What if I did this? Let's do this in another color so we don't get it all mixed up. I think I might be getting a little ahead of myself, but that's okay. I'm thinking about it, so I might as well do it. What about that? Oops, I thought I was changing the color.
That would be a double ray radian.
There we go. What about that thing right there? Is it a radius?
No,
It's a line segment.
but it's not coming from the middle.
That's right. Not middle. We don't say middle. What is it? It's the center. Okay, on the circle we always call it the center. Right. It doesn't hit the center of the circle. It's not a diameter because it doesn't hit the center. It's just a line segment that connects 2 points on the circle. Right. That doesn't necessarily go through the center. All right. We call that thing a chord. C-H-O-R-D. So that red one would be called a chord.
It has no letters.
Well, I could put letters. X, Y. All right. So that's a chord. It doesn't have to have letters. It doesn't have to have points labeled in order for it to be a chord. As long as you know it hits on the circle here and it hits on the circle here, that's considered to be a chord. All right. What else could I say the diameter was? Like FB. FB is a diameter, but it's also something else we just talked about.
2 radii.
Yeah, it is 2 radii, okay, opposite radii, but we just talked about it. I think I heard somebody whisper it. It's a chord as well. The diameter is also a chord, but the diameter is a chord that just happens to do what? Go through the center of the circle, okay?
See how
Yes, you did. All right, everybody see that? So the diameter is also a chord, all right, but it's a chord. It's a specific type of chord. It's a chord that goes through the center of the circle. Everybody good?
Yeah.
All right, I think we've covered that enough. We're going to talk. We're going to do one more thing about a circle a little bit later on. Okay, so don't put circles away just yet. Look at this thing. In fact, do you see my little computer program? See this little thing in blue right there? Can anybody up front read that? What's it say? Polygon tool. Okay, and that's what we're going to do. And this thing right here lets you pick how many sides. So how many sides do you want? I don't want too many. 8? Let's do 8. All right. So there's 8 sides. Now look, I could take this. I could make it like that. There's still 8 sides, right? Doesn't matter if it's like this, if it's like this. That wouldn't be a stop sign, though, would it? That wouldn't be a stop sign. When would it be a stop sign? Yeah. When all the what? What do you think?
When they're all congruent.
All what are congruent? All the sides. That's right. Okay. So this thing right here we call a polygon. Now, a polygon. Well, listen. I was about to say that. Polygon. What's the prefix poly mean? Anybody heard that before? Many. It means multiple. It means many. Right. Okay. And the gon is just short for an angle. All right. So it's basically it's a closed figure. It's got to be closed. There can't be any gaps. Like this line segment can't come up here and it can't come up here and not touch. They've got to all touch. It's got to be closed. So it's a closed figure that consists only of segments. All right? It's a closed figure that consists of segments. It doesn't have to be nice and perfect looking like this. All right? As long as you got line segments and they're all connected, then or connected at the endpoints. Let's say that. They're all connected at the endpoints, then it's a polygon. This is just a specific type of polygon, one that has 8 sides. I could do another polygon, so let's go to that thing again. And I'm going to go to polygon, and if I tap, whoops, sometimes, if I tap, it'll ask me how many sides. Let's put 5 sides and see what that looks like. 5 sides. And let's do it. Here we go. Yeah, there we go. All right, so this is another polygon. It's just a polygon that has what? Come on, if I could. Come on. Grab it. Grab it. It looks like it should be grabbing it right there. Why isn't it grabbing it? There it goes. Whew. All right. And then we could keep doing it with a whole bunch of sides, couldn't we? Now look, if I wanted to, I could be real silly. And let's do like 100 sides. Okay. Look at that. It looks like a circle, but is it a circle? Let's zoom up. What's all those dots all around it like that? What's going on? Look at this. What's going on with this? I can only zoom up so far. I don't know if you'll be able to tell or not. Let's zoom up as far as I can. That zooms in a lot. Let's see if I can find it now. Come on. Where is it? I zoomed up so much. Let's see. Let's zoom out. Let's zoom out a little bit. There it is. I'll tell you what I'll do. Let's just do this. I think if I click on that, give me a minute. Okay, now if I zoom on that, there we go. Now if I zoom in some more, let's give me a second. Now I probably overdid it with 100, but it looks like a circle, but really there's so many sides, right, that even if I blow it up really easy, you can kind of see a little bit of a bend right here. Like if I click on it, I think if I click on it and move it around, I don't know. Well, anyway, I didn't mean to do that. Sorry. Okay. Doing 100, but you could.
It may look like a circle,
but they're all straight sides, right? And the more and more you have, right, the more rounded it starts to become, right? If I put 1,000,000 on there, it would look really like a circle, okay, and that kind of thing. So, anyway, those are polygons. Let's talk about a couple things. I got off track a little bit. Sorry. Do you see where all the line segments join together? Okay, we have a name for that, and we've talked about this before. We talked about it when we talked about angles. Right up here. We talked about this when we talked about angles. Any idea? This makes an angle, doesn't it? No? That makes an angle, doesn't it? All right, so I've got a line coming here, a line coming here. What did we call that on an angle where they come together? Say it. Did I hear anybody? No? If I tell you what letter it starts with, you'll get it. If you had an angle, if you just had like an angle like this and like this. Now, I'm not asking if it's obtuse or acute or anything. I'm asking, what is that point? This point, right. On an angle, that's a vertex, isn't it?
Yeah.
Well, this also forms an angle, doesn't it? So guess what we're going to call this? Matthew, up here. We're going to call this a vertex as well. So that point right there, okay, is called a vertex. But it's a vertex of a polygon. There's a lot of vertexes. Is that how the plural is? Vertexes?
No.
Did I ever give that to you? Verti? That might be. That sounds kind of cool. It's actually vertices. Okay, vertices. That's the plural for vertex. All right, so I've got a vertex right here. There we go. Now, somebody already said this. What about the line segments themselves? What do we call that on the polygon? Somebody said it earlier. We had 8 what? We had 8 what?
Lines.
Yeah.
Congruent lines.
Sides, right. I heard somebody said it earlier, okay? So we have sides. So each one of these line segments is a side, all right? So if I said, so how many sides does this polygon have?
8.
8, all right? Count them up. How many sides does this polygon have? 5, okay? It also has the same number of angles, doesn't it?
Yeah.
All right, because if you count up all the angles, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 angles on there. There's 5 sides, 5 angles. There's 8 sides, there's 8 angles. Everybody got it? All right, that's important to know as well. Let's see what else I want to say about this. Okay, if you notice, on all these right here, I made it. I hit the shift button, then made the polygon. Tim, I'm talking. Apparently you are too, but I'm the one that's supposed to be talking. So when I made this thing, I hit the shift key to make this octagon. And what did that shift key do? What do you think it might be true about all the sides of this thing? They're all congruent to each other. So this. But there's little tick marks. Remember that? Means they're all equal to each other. Okay? So they're all congruent to each other. So if I have a polygon, when all the sides are congruent, all the sides are equal to each other, I have a special name for that. Okay? And I call it an equilateral polygon. So write that down. These are words that we're going to be using quite often throughout the year. And you need to know what I'm talking about. So if I say it's equilateral, or the book says these two things are equilateral, you need to know what that means. That means all the sides are equal to each other. Okay, so it's an equilateral polygon. And what does that mean? All the what? All the sides are equal. The word lateral means sides. All right. I would say this all the time. I played basketball when I was in high school, and we did this drill where the coach would have a whistle. They do this in probably several different sports. They blow the whistle, and then they move the ball to this side. So everybody shuffles to this side with their feet. Then they blow the whistle again. They move it over here. That's the lateral drill. You go side to side. Okay, so lateral means sides. And so it's equa. So what word do you think is in there? Equal. Right, so it's equal sides. So a polygon with equal sides is an equilateral polygon. What about all the angles? On this one, again, I made this so that all the angles were exactly the same. So I can put little arcs on all of them. Okay, so if all of them have one arc, that means all the angles are exactly the same. So we give that a name as well. And we also use the equa to begin it, and then we use angular. That's how they say that. So an equiangular polygon. Now, you can have an equilateral that is not equiangular. And you can have an equiangular that's not equilateral. All right, I'm not even going to try to draw them, but you can have that. But what if both of these things are true? If all the sides are equal and all the angles are equal, we have a special name for that kind of a polygon. This is true when both things are true. Okay, when it's equilateral and it's equiangular. So okay, if they're both, we call that a regular polygon. And that's really important because we're going to be doing some stuff a little bit later on in another chapter. We're going to do stuff with regular polygons, and it's very important that you understand what a regular polygon is. So a regular polygon means that all the angles are equal to each other and all the sides are equal to each other. It's equilateral as well as equiangular. That's pretty easy to see, isn't it? Yeah. All right, so now what we're going to do is we are going to do a thing called classifying our polygons. So we have special names for a certain amount of polygons. All right. It doesn't matter if they're equiangular or equilateral or anything like that, but we have special names. So here's what I'm going to do. We're going to make a list, and I would write down this list if I were you. So I'm going to talk about the number of sides that a polygon has, and I'm going to talk about the name of the polygon. Okay, we have specific names for certain ones. By the way, what's the smallest number of sides you can have on a polygon?
3.
3. You can't have 2 because if you had 2, there's no way that can be a closed figure. Because watch. And it gets closed. So once it closes, but is there anything inside it then? No, it's just one line on top of another. All right, so You can't have two sides, so the least number of sides you can have are 3. So let's start with that. So everybody should know quite a few of these. Some of them maybe you know, some you don't. That's absolutely right. That's a triangle. All right? Tri meaning what? 3. Now this one right here, what if you had 4 sides?
Square. Rectangle.
Is it a square? Is it a rectangle? What if I had 4 sides, and my 4 sides look like this? No, it's not even a trapezoid.
Equilateral.
But that's not a square, is it? It's not a rectangle. It's not even a trapezoid, Amy. It's a quadrilateral. Exactly right. So if we want to be real general, and we're trying to be general here, okay, we call it a quadrilateral. So that's one that you don't hear too often until you actually get into geometry. But we call it a quadrilateral. That means any closed figure with 4 sides. Okay, it doesn't have to be right angles. It doesn't have to, be a rectangle. It doesn't have to be any of those things. Okay, we have a bunch of different names for 4-sided figures. You could have a rhombus. Have you ever heard of rhombus before?
Yeah.
Okay, we'll talk about a rhombus later on. What was the last thing we just said? The other thing.
Square, rectangle.
No, somebody said some fancy trapezoid. Right. For some reason, I couldn't think of that. So a trapezoid's a 4-sided figure. There's also a thing we're going to do later on called a parallelogram. There's a lot of different 4-sided figures, a lot of different quadrilaterals. And I don't know if we have a whole entire chapter on quadrilaterals, but I know we got a big chunk of stuff that we're going to learn about quadrilaterals. But quadrilateral just means a closed figure, 4 sides, and that's all it means. All right, let's keep going. 5, it's a pentagon. Very good. There's a building in Washington, D.C., isn't there? Called the Pentagon. Has anybody heard of that? Yeah, and it looks like a pentagon like we just did up here. From the sky view, it looks just like that. All right, except like you got lines going like this, and like this, something like that. Because it's got a bunch of hallways, right? And so this is like where all the buildings, let's see. So like all in here, like office buildings or offices and stuff like that. And it goes high. I don't know how many stories it is, but it does go a little bit. It's not crazy high. It's not skyscraper high. I don't know. They have like 5-6 floors maybe. I don't know. You could always look it up. I have no idea. But anyway, that's a pentagon. So let's keep going. So that's a pretty famous thing. 6 is a hexagon. So hexa is a prefix for 6. 7's kind of weird. Depends what book you look at. The first year I taught geometry at a different school, they called it a 7-gon. They didn't even give it like a real name. They just called it a 7-gon. I'm like, that's kind of lazy. But this book calls it a heptagon. Hepta. All right, so that's for 7. 8 we talked about already. What did we say in 8? Octagon. And somebody's already mentioned this, but let's mention it again. What do you see probably every day, at least when you come to school? What do you see? A stop sign, and that's an octagon. And it's not just any old, just wait till I'm done teaching. It's not just any old octagon. What is it? It's a regular octagon, okay? So if you go up, you can hang on to it. Just don't give it to me while I'm trying to teach. That's all I'm saying. So if you go up to a stop sign, and if you had a protractor or something, you measured the angles, you'd find out that all the angles are exactly the same. If you had a ruler, you could measure all the sides of a stop sign, and all the sides would be exactly the same. It's a regular octagon. It's something you see probably every day, at least every day you go on the road. Now, here's a weird one. 9, they call it a nonagon. Don't really hear about these very often, but that's what they call it. 10's pretty famous. What's a prefix for 10? Deca. Right, because decade is how many years? 10. So deca, right, is the prefix. So it's a deca, what? Gon. Right? And they give you a couple other ones that you'll rarely ever use. I didn't even know the name of an 11-sided polygon until I looked in the book, and they call it a hen decagon. That's weird. So it must be some kind of prefix. I never really looked it up. I really don't care. I'm not that interested, to tell you the truth, to even look it up. All right, but they call it a hendecagon. All right, 12, I've heard every once in a while. This is used a little bit. They call it a dodecagon. dodecagon. And again, my feeling is there's probably some meaning behind the doe and behind the hen and all that kind of stuff. I don't really know what it is. You could always look it up and tell me, right? Then after that, we don't really have any names for them. So if we had like n number of sides, represents any number of sides, we would just call it a n-gon, right? So if you had 15 sides, there's no special name for it. We just call it a 15-gon. Or you know what I would say? I wouldn't say a 15-gon. I would say it's a polygon with 15 sides, right? And the one we did with 100, I would just say it's a polygon with what? 100 sides, okay? That's how I would usually say it. All right, so there's a list for you. And it's important to know some of these because they'll talk about it. It might give you a problem in the book where that says, okay, you have or what are the, we're gonna have a problem later on that's going to say, what are the sum of the angles of a regular octagon, right? And that's what they say. And so you got to know what a regular octagon means, all right? So make sure that you do know those things, all right? When are we out of here? 10 till?
50.
Do you know what that means?
50.
Yeah, that's 10 till.
10,
10 minutes until the hour. You ever
saying a quarter of, like,
right, quarter of, 10 of, 10 till, 10 of, right. That's how old people tell time.
I remember,
Okay.
I remember we were on Fortnite and you said 37 till.
All right. Let's do this. 1, 2, 3, 4, 5. So let's draw. Tell you what, we haven't done a hexagon yet, have we? So let's do a hexagon. Let's put 6 sides. All right, so there you go. It doesn't matter what this is.
You just want us to draw that?
If you want.
I'll draw it, because I'm actually a pretty drawer.
Good.
You suck at drawing.
All right, here we go. I'm going to show you something that we're going to use at some point. Not right now, not in this chapter, to tell you the truth. But this is just kind of warming you up and getting you ready for something. So, I forget what chapter we're going to do this stuff in, but what if I did this? What if I connected one vertex to another? Okay? But what I'm doing is I'm starting at one vertex, and I'm connecting, listen to the words, I'm connecting to a non-consecutive vertex. What do you think that means, non-consecutive? What does it mean to be consecutive?
Like one of the ones that isn't after another.
One after another, very good. Consecutive just means one after another after another. So, which ones are the non-consecutive? The ones that are not right, or that are not right next to it. So look, if I start here at this particular vertex, I want to draw line segments from one vertex to another from here, but I can't go to the consecutive vertices. So I'm not going to draw one here, and I'm not going to draw one here, okay? And there's a reason why we're doing this, but today it's basically just vocabulary. We are going to do something with this later on, okay? And I kind of alluded to it a little bit. Remember when I said find the sum of the angles of a regular octagon? Okay, we're actually going to do that. We're going to find out what do all these angles actually add up to be, all right? On if you had 6 sides, or if you had 8 sides, or if you had 10 sides, or whatever, okay? But we're not going to do that today. But all I'm trying to show you is this, is the red lines right there, they are called diagonals. Okay, so those are the diagonals of a polygon. All right, and let's put some letters in here. We'll just call it A, B, C, D, E, F. All right. So we need to be able to name a polygon. All right. So you don't have to say it's a hexagon in this situation. If I name it, what we're going to do is we're just going to say it's polygon. We don't even have to say hexagon. We just say it's polygon. And then what we do is we start at a letter. It doesn't matter what letter you start at. All right? We can start at A if you want to, if it makes you feel any better. Or since all the diagonals start at F, we could start there too. Again, it does not matter which one you start at. Okay? Let's just start at A. It's a little easier that way. Right? So if we start at A, right, I could, if I'm going to name this polygon, I could start at a particular point, and then I have to go in order around the polygon. Now, it doesn't matter what order. It doesn't matter which direction you go. You could go this way, or you could start at A and go this way. So let's finish up with this. So what could we call it? Polygon what? A, B, C, D, E, F. Or I could go the other direction. I could call it what? A, F, E, D, C, B. Or I could start at E and I could go this way or go that way. All
There's
right?
probably like 30 different ways. to do
There's
it.
probably. All right. Did I give you any kind of homework tonight?
I
I
don't know if we went over it. Was the homework we
Just listen. Yeah, I did. Listen to me. Listen to me. Listen to me. So you hear my instructions. I did give you homework tonight. It's 13 to 20, 31 to 43. We may or may not have gotten to everything, but do as much as you possibly can up to the part where we learned today, okay? So do as much as we can. I don't have the homework in front of me, so I can't tell you exactly how far we've gone compared to what the homework is. But do as much as you possibly can, and we'll try to finish this up tomorrow.